As per request, this video will be all about Spatial Query and OverlapParams, which were added to Roblox around 2 years ago and are extremely useful for basic hitbox detection without having to get all complicated with things like the .touched event or arraycasts. Spatial Query API provides three main functions, all of which are called on the workspace object: getPartBoundsInBox, getPartBoundsInRadius, and getPartsInPart. What each of these does is rather self-explanatory, but I'll go into more depth on the specific details and arguments that go into each of these functions. First off, we'll look at workspace getPartBoundsInBox, for which we'll insert a regular script into server-script service. What you call this script doesn't really matter, but we'll create a variable called parts and set it to the result of workspace getPartBoundsInBox. As you can see, there are three arguments that this function takes. The first being a C-frame for the origin, position, and orientation of the box that you want to detect items in. The second argument is a vector3 object which determines the size of the collision box, so we'll put a basic size of 10 all around to make a cube for testing. The final property is an OverlapParams object, but we'll get to that later, and for now we'll move this code into a repeating while loop and add a print for the parts variable to see what parts were hit. Seeing as the tables are all closed, it makes it very difficult to see what's what, so we'll go to the output and turn on Show Tables Expanded by default, so we can see the detected parts changing as we enter and exit the hitbox. In order to better visualize where the hitbox actually is, so it's more intuitive to see for testing purposes, we'll create variables for the C-frame and the size arguments and create a new part, turning anchored to true and canCollide, canQuery, and canTouch all to false, setting the C-frame and size to match the variables we created so it's a perfect match of our hitbox. Finally, set the transparency to be translucent and set the parent to the workspace so we can actually see the part in-game. Testing it again, it functions the same, but we can actually see the hitbox and see how the printed table changes as we move around in and out of it. We can also see that it detects parts even if they're barely touching it, so long as they are, and that overall it's pretty accurate to the box. Now, if you wanted to use this for a hitbox, you'd want to take these parts and find the characters based on these parts. You can do this by creating a new table for all the characters that have been hit and running a for loop through each part, checking if the part's parent has a humanoid inside it and if the part's parent isn't already found inside the table. If both of these conditions are true, we'll insert the part's parent into the table we created and we'll print the final table at the end of the loop at the bottom. Now we can see it doesn't print all my character's individual parts, but my character model itself. We can also see that since it only detects if the part's parent has a humanoid, it also works with non-player characters as well without any extra adjustments. For now, we'll disable that script and insert a new one to have a look at getPartBoundsInRadius this time. We'll create a while loop just like before and make sure to add a wait at the bottom. We'll set a variable called parts to the result of the workspace getPartBoundsInRadius. As you can see, this method has three arguments: position, radius, and the overlap params from earlier, which I still haven't gotten to yet. The position is a vector3, so we'll set it to be 8 studs from the center position of the world, and the radius is a number, so we'll just set it to be 5 and print the parts variable we created. We can see that it seems to function rather similarly to the hitbox we had earlier, but it's actually a sphere instead of a box. To show this in more detail, let's create a display part in the same way we did before, setting the position and radius to variables and creating a new part instance. We'll set anchored, canCollide, canQuery, and canTouch to the same values as we did before, and then set the size to be a new vector3 of the radius for all axes, but multiplying the whole thing by a scale of 2. We'll set the position to the position variable, the transparency to 0.5, and the parent to the workspace. Finally, we'll set the shape property to enum.parttime.ball, so it's a sphere rather than a box. Now we can see the hitbox in much more detail, noticing that it actually functions as a sphere rather than a box, which is great for area of effect hit detection, or finding anything within a certain radius if you're not wanting to use magnitude. Now you can do the same thing we did before to find the actual characters that will hit, rather than the parts. As you can see, it functions the same, but with a spherical hitbox instead of a box. Disabling that script and inserting yet another, we'll test out the final method, getPartsInPart. This one uses an actual part rather than variables that define position and size, which allows for more flexibility in the case that you wanted a moving or changing hitbox. We'll create a new part in basically the same way we created the display parts for the other hitboxes, but except we'll use this part as the hitbox itself rather than just a display of it. We'll run a while loop just like before, setting a parts variable to be workspace getPartsInPart, and providing the part as the argument, printing the parts table. Also make sure to add a wait to the while loop, which I forgot to here. As we can see, this hitbox seems to function basically the same as getPartBoundsInBox, except that the main difference is that it actually follows the part if we change the part, whereas the other two hitboxes are always the same. I believe this method also respects the specific collision shapes for meshes and other types of parts as well, if you wanted a more specific kind of collision shape. Again, we can find the characters that were hit by looping through the parts table just like before. Testing it, we can see it works the same. Finally, let's get to the last argument of all three of these functions, OverlapParams. OverlapParams is basically the spatial query version of raycastParams and has many of the same properties. Inside the getPartBounds and box script, which we'll re-enable, we'll create a new OverlapParams and test the properties one by one. Here you can see a list of all the main properties and methods of OverlapParams, but we'll just go over the major ones for now. We'll first look at the filterDescendantInstances property, for which we'll actually first remove the canQuery and canTouch properties we set to false for the display part from earlier. We'll also comment out the findingCharacters portion and print the parts table again. Now you'll notice that the display part is actually being detected in the hitbox unlike before now that canQuery is off. To demonstrate filterDescendantInstances, we'll create an OverlapParams object and set the filterDescendantInstances property to a table which contains just the display part we made. And finally, we'll make sure to add the params object as a final argument to getPartBounds and box, and you'll notice that now the hitbox detects our player's parts, but not the display part since we added it to the ignore list. Another thing we can do is run addToFilter on the params object, adding all the parts that were hit to the filter, making so each part can only be hit one time rather than multiple. If we add the code for finding characters back, we can add the character models instead, and it'll make so each character can only be hit once, which is also super useful for hitbox detection. For example, if we comment out the addToFilter function call and find the humanoid for each character, making them take 10 damage, you'll notice the code just rapidly damages me and kills me instantly. But if we add the addToFilter function call back, you'll notice it only damages me once, no matter how much I move around or play in the hitbox. Next, we'll look at the filterType property, which has two main options, include and exclude. Exclude is a default, but with include it essentially makes so only the parts in the provided list can be hit and all others are ignored. If we comment out the characters portion and just print the parts again, you'll notice it only ever hits the display part and never detects my character. If we switch include to exclude, you'll notice it functions the same as before, ignoring the display part. Next is max parts, which basically limits the amount of parts that can be detected at a time. If we set it to 1, only one part can be hit at a time, but if we set it to 5, up to 5 can be. Another property is the collision group property, which is a reference to physics service collision groups, which I won't go into too much detail on, but it basically allows you to determine specific things that do or don't collide with one another, even with can collides set to true. I'll provide a link for more information to physics service in the description of this video. Thanks for watching the video and I hope you guys enjoyed. Let me know if you guys want any other quick videos like this on topics like spatial query or raycasting that can be a little tricky if you're just looking at them for the first time. For channel members, the file for this video will be in the members category of the 9 Scripting Lessons Discord server as well if you want to see an example of a basic attack move I added that uses the spatial query functions for hit detection. I hope you guys enjoyed the video and I'll see you guys next time.